This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to take a look at how to change rectangular equations into polar equations. Our first section, we're going to take a look at the equations that allow us to do this conversion, and then we're going to take a look at two examples. Let's get started. So here are the equations that allow us to convert between polar and rectangular form. Where do they come from? It's a great question that you asked. And to understand that, you have to draw a right triangle. I'm going to do my best. I keep on botching this up. Yep, that's as good as it gets. Let's talk about this. Well, we know that this is the x value. This is the y value. And I know that this is the r value. Pythagoras says that x squared plus y squared is equal to r squared. I know that this is theta, my angle. And remember, tangent is defined as opposite over adjacent. There's the other one right there. And if you think back to vectors, we know that if I take the cosine of this angle, it's x over r. So cosine is x over r. Yeah, a little bit of algebra will get you to x equals r cosine theta. And likewise, I know that the sine of theta is opposite over hypotenuse, or y over r. And a little bit of algebra will get you to y equals r sine theta. All right, let's use them and on a couple examples and see how it goes. So let's start with a circle. Matter of fact, I'm going to start with a really simple looking circle. Let's say x plus 3 quantity squared plus y squared is equal to 9. Now we know that this is a circle that's centered at -3, 0, and it has a radius of 3. So what does this look like in polar form? Okay, well, let's do a little bit of algebra. If I square this, that means x plus 3 times x plus 3. I get x squared plus 6x plus 9. I can move the x squared and the y squared next to each other, move everything else on the other side. So that means move this the 6x over to become -6x, move the 9 over to become -9, and remember I do have a 9 sitting there already. Okay, so what is this? Well, x squared plus y squared is r squared, and I'm going to replace that. Let's see, what's x? Hey, x is r cosine theta. So that's r cosine theta. And what's, well, -9 plus 9 is Zippo. There you got it. So what I'm going to do now is I'm going to move the other term back over again. So I moved it over, and I got a 0 on this side. I'm going to factor out an r. Why? Well, because there's an r in common. So if you factor out the r, whoop, this is what you get. Now if I have two factors whose product is equal to 0, I could set the two products equal to each other. Yep, it's the multiplication property of 0. Product property of 0 goes by many names. All right, so what is this? R equals 0. Picture what in polar form would give you a radius of 0? Well, it's a circle. Anything that's got a radius, when you just say the radius is one number, it's a circle, but it's a degenerate circle, which means it shrinks. Its radius is 0. So if you have a circle with radius 0 centered at the origin, basically it's a point at the origin. So this is just a point at origin. So nothing to worry about. It's really no big concern. All right, now let's move the r back over to the other side for this equation. I'm going to get a -6 cosine of theta. And there you have it. You have this. If you were to plug this into a calculator, you would see that it is a circle that's centered at -3, 0 with a radius of 3. Kind of neat. Okay, let's go on to another example. Well, let's take a look at a line. let's say we were to start with the line y equals 5. Is it vertical or is it horizontal? Well, if it's y equals something, it's definitely going to be horizontal. So what does a horizontal line look like in polar form? All right, well, let's see. What's y equal to? Y is r sine theta. Okay, now what? Well, I want to get the r alone. So I'm going to divide both sides by the sine of theta. If I divide both sides by the sine of theta, I get that. 5 over sine theta. Sorry, my 5's and my s's kind of look alike, which is why I try to stay away from that. But anyway, I divided both sides. I got that sine over there. But if you remember anything from your trigonometry and your inverse, or sorry, I should say reciprocal functions, the reciprocal of sine is cosecant. All right, well, if you plug this into a graphing calculator, you will notice that yes, it is a horizontal line. And that's it. Okay, I wanted to show you a couple quick examples, and there you have it. You had 2 quick examples. Please make sure you like this video. I really appreciate it if you were to do that. And also make sure you subscribe to our channel, as we do provide, as MathGuide does provide, helpful videos for your math education. And make sure you go back to MathGuide, check out our text-based lessons, our interactive quizzes, and more instructional videos. Have a great day.